Will Dr. D, shall we begin?
Yes, we can begin.
All right. So good morning and good afternoon, everyone. My name is Khalil Raza, and I'm working as the scientific officer at the Economic Cooperation Organization Science Foundation. In short, it's called the ECO Science Foundation. So it's an intergovernmental agency of 10 member countries, including Afghanistan, Azerbaijan, Iran, Kazakhstan, Kyrgyz Republic, Pakistan, Tajikistan, Turkey, Turkmenistan. So on behalf of the BTPU ECOSF Joint Training Center, I welcome you all. And I'll be today's moderator for the session. So this is our fifth series of our training program. Previously, we have held these similar trainings on different themes and titles. So in terms of low carbon development, this is the second part of this. So this program is focused on pathways for industrial decarbonization in the Belt and Road countries. Before I move on to formal proceedings, I would like to give you a quick announcement for interpretation. So this, as one of my colleagues has already announced, that this training provides simultaneous interpretation. So in the Zoom interface, you will have option for the language over Zoom app. So if you are using computer, navigate at the bottom of the screen, and you would see interpretation. And then you select English if you want to have an English in it. And for mobile device, you have similar interface as well, and then select English for us. So at this stage, we request all the participants to please mute yourself. And I see some of the participants, they have named, with their iPhone or the phone devices, like some of they have like Galaxy or iPhone. So if you want your certificates for this training program, especially towards the conclusion, will only be able to give you the certificate if you can rename it to your original name, not your device name. So this is again a request. So please rename your the title of your representation, your name and organization, comma, like for instance, my name is Khalil Raza and my organization ECOSF, you could just name it that way. And if you have any questions or queries, please put them in the chat box and we'll take them at the end of the session at the Q&A. Just a quick intro to BTPU ECOSF Joint Training Center. So this is a joint initiative of the Beijing Technology Business University and the ECO Science Foundation, which was with the purpose to build a human resource capacity in key infrastructure and industrial development areas for the Belt and Road countries, especially in the emerging technologies, engineering, infrastructure, etc. So let me tell you why we are hosting this particular training on the industrial decarbonization. Because as we deliberated in our last training on climate change, that the climate change and its adverse effects are the common concern of the mankind, and they would continue to push us to go into cleaner transition so that we could avoid the devastating impacts of the climate change. And a number of countries have pledged to reach net zero emissions by mid-century, and China is among them, and most of the European Union members, as well as some in the South Asia Pacific, they've also pledged net zero targets. So in terms of power sector and other areas, it's quite, it's not, I would say it's not as challenging as in the industries to decarbonize. So we all know that much attention is given to power sector because we have the technologies such as green and renewable clean technologies, energy efficiency, etc. So the important part here is that we need to work on those areas in industries which are hard to decarbonize. And we want to understand how China is undertaking this strategy to decarbonize their key industrial sector, for instance, cement, steel, fertilizer, and chemicals. Although these have a high, significant, substantial potential for decarbonize, but it's particularly challenging to decarbonize the sector because of their inherent greenhouse gas emission mitigation. To discuss this, we are excited that we have an excellent panel of experts that will look forward to learning from them their strategies. It is also important to understand and share the best practices and experience that they have already adopted and they have the plans to implement in the near future. So without a further delay, I would like to welcome President ECO Science Foundation, Professor Dr. Manzoor Hussain Soomro, to deliver his welcome speech. Over to President ECOSF, Professor Manzoor Hussain Soomro.
Thank you very much, Khalil. Your Excellency, Mr. Liu Minhua, the Vice President of Beijing Technology and Business University, Dr. D. Yuna, Khalil Raza, and distinguished participants, colleagues, ladies and gentlemen. Good morning and good afternoon to you all, wherever you are. It's my immense pleasure to welcome you all to our 5th joint training program of the BTBU ECOSF Joint Training Center with a focus on pathways for industrial decarbonization in the Belt and Road countries, as Khalil already mentioned to you. I would like to extend my deep appreciation to the leadership of Beijing Technology and Business University, the BTBU, for their continued cooperation and patronage. My special appreciation to Dr. D. Yuna, the director of the center and coordinator on Chinese side, and my colleague, engineer Khalil Raza, who is coordinator on the ECO Science Foundation side, for their efforts towards promoting the low carbon development in Belt and Road countries, including the ECO member states. I particularly applaud their hard work in designing and preparing for this workshop as well. Well, ladies and gentlemen, we are very well aware that the impacts of climate change that are occurring with increasing severity and frequency, all nations are vulnerable, but generally the developing countries are even more vulnerable and less resilient with limited resources for both mitigation and adaptation. This situation calls for an urgent need for us to make more investments in technologies and processes to promote climate smart solutions for our planet. Worldwide, the current development path that we have been pursuing is based on fossil fuels and consume substantial energy resources while producing abundant materials and benefiting the mankind. However, it also has a negative impact on the natural environment, and this negative impact is intensifying. Hence, the balance between carbon-intensive processes and the environment is the greatest challenge facing the mankind today. And I believe it is very timely to discuss low-carbon industrial development, as aggressive adoption of such technologies will be an essential prerequisite for the Belt and Road countries to collectively move closer to more ambitious target of reducing the GHG emissions and containing the increase in temperatures. We know what actions we need to take to cut emissions, and the industrial decarbonization for sure offers the substantial emission mitigation potential. We also know what policies are necessary to drive these actions, which are to incentivize research on climate smart solutions, carbon trading and regulation, increase technology support, and measures that protect the environment. Dear participants, as you know, clean energy is critical for achieving sustainable development, and is at the forefront of global agenda. Technology plays a key role in promoting sustainability in many areas, including energy and sustainable industrial development. But the countries of the South, especially in our region, face a range of challenges in obtaining, adapting, and effectively using industrial technologies, not to mention in building the productive capacity. I'm extremely pleased that leading experts from China are going to share their insights and success stories and the elements behind the massive technological advancement that China has achieved in the achieving their climate targets. However, I would like to say that to reduce emissions and accelerate green growth, we need development and diffusion of technological innovations. And the low carbon development challenges cannot be met by just applying carbon efficient technologies in certain economic sectors and leaving others unchanged. The implementation of beneficial technologies is needed holistically and across the sectors. Ladies and gentlemen, I truly believe that the successful transition towards low carbon development would heavily depend on fostering public-private partnership that can accelerate development of technologies, promoting research and development, and human resource skill development. Hence, the critical challenge for us is to enable the delivery of our national development delivery of fostering the public-private partnership that can accelerate development of technologies, promoting research and development, and human resources skills development. Hence, the critical challenge for us is to enable delivery of our national development visions and goals through low carbon technologies. I am confident that this training would be very beneficial for our participants and will go a long way to build major partnership and linkages around the Belt and Road countries and the ECO members as well, including Pakistan, towards the green growth technologies. Rest assured that our BTBU ECOSF Joint Training Center will continue to deliver trainings to build human resource capacities of participating countries in the important areas of scientific and technological research with the development and socio-economic impact in the region. I thank you all very much and wish you a very beneficial training workshop for today and for tomorrow. Thank you all very much.
Thank you, President ECOSF, Professor Manzoor and Soomro, for your welcome remarks and important recommendations for this training. Now, I would like to invite, and it's my great honor to have ZHU Fahua, Deputy General Manager of Science Technology Research Institute in China Energy Investment Company, China Energy in short, who has been the director of the National Key Laboratory of Atmospheric Physics, Physical Simulation and Pollution Control. He has also been a doctoral supervisor of Nanjing Information Engineering University. He has served as an editor-in-chief of Power Science and Technology and Environment Protection. He's the deputy editor-in-chief of China Electric Power, and he has so many other things that it would take me so long to announce, take all his credentials. So Professor ZHU Fahua is going to speak on the policies and practices for low carbon transition in coal power industry. Now, it's very important that coal is not a low carbon, it's a high carbon. So how you make it low carbon, it's going to be an interesting talk. Over to you, Professor ZHU Fahua.
先生们、女士们，大家好！非常感谢主持人的介绍，也非常感谢北京工商大学经济合作组织科学基金会邀请我参加第5期培训。我非常荣幸跟大家做一个交流。我跟大家交流的报告的题目是《煤电行业低碳转型政策与实践》。刚才主持人也对我做了一个介绍，非常感谢哈。我同时也担任这个电力科技与环境保护这个期刊的主编。我报告的内容主要分3个部分：1政策，2实践，3目标。中国在低碳领域的政策，应该说在2004年就已经开始。2005年被作为中国二氧化碳减排的基准年。这些年来出台了很多的低碳领域的相关政策。那么在关于煤电机组建设和改造方面，有5个重要的政策我想跟大家一起分享。第一个政策是关于燃煤电站项目规划和建设有关要求的通知。第2个是关于加快关停小火电机组热干意见的通知。第3个是关于严格控制重点区域燃煤发电项目建设规划建设有关要求的通知。第4个是煤电节能减排升级与改造行动计划2014到2020年的通知。第5个是关于开展全国煤电机组改造升级的通知。第一个政策是2004年发布的。这个政策规定，所有的新建的机组都应采用60万千瓦以上60万千瓦及以上的机组，发电煤耗要控制在286克标准煤每千瓦以下。那么在东部就是缺煤的地区缺少煤炭资源的地区，建设的煤电机组煤耗不高于275克每千瓦时。那么在煤炭资源丰富的地区也要控制煤耗，就是295克标准煤每千瓦时。控冷机组要控制在305克标准煤每千瓦时以下。那么第2个政策是2007年发布的，就是国务院批转是国务院批转的国家发改委和能源局关于加快关停小火电机组热干意见的通知。那么在这个通知里面明确，15期间，也就是2006年到2010年，在大电网覆盖范围内要逐步关停落后的机组，具体包括单机容量5万千瓦以下的常规火电机组，运行满20年单机10万千瓦及以下的常规火电机组，按照实际寿命服役期满单机20万以下的各类机组，供电煤耗高出本省05年平均水平10%和全国平均水平15%的各类燃煤机组，未达到环保排放的各类机组，按照国家有关法规明确要求关停的机组，这就是要求关停小机组。同时，这个政策里面明确就是新建的机组可以 直接纳入国家电力发展规划优先安排的主要是单机容量30万千瓦，替代关停容量的，就是关停小机组的容量达到自身容量80%的项目。那么单机容量60万千瓦的，替代关停机组容量要达到自身容量的70%，单机100万千瓦的，替代关停机组的容量达到60%那么就是单机容量越大，替代的容量的比例越小就是鼓励建设大容量机组那么单机20万千瓦以上的热电联产项目，替代关停机组的容量达到自身容量的50%。第三个政策就是国家发改委环境保护部关于严格控制重点区域燃煤发电项目规划有关要求的通知。那么在这个规划当中要求里面，对不同类型的机组对供电煤耗和这个厂用电力都做出了严格的规定这个是2014年发布的第四个政策就是煤电节能减排升级改造行动计划那么这个也是对14年发布的，对各类机组供电煤耗和这个在约机组、新建机组都分别做出了相关的煤耗的规定。第五个政策是2021年发布的关于全国煤电机组改造升级的通知。那么在这个通知里面就明确要求按照特定要求新建的煤电机组，除特殊要求外，原则上采用超超临界其供电煤耗低于270克标准煤每千瓦时的机组，而且明确到2025年，全国火电机组平均供电煤耗降至300克每千瓦，300克标准煤每千瓦时以下。“十四五”期间，也就是2021年到2025年期间，要实现煤电机组灵活制造规模1.5亿千瓦。那么灵活制造实际上就是可以实现深度调峰促进就是风电和光伏发电的上网。那么在今年就是几天前中国政府又发布了最新的关于煤炭清洁高效利用重点领域标杆水平和基准水平的通知那么在这个里面这个是最新的政策。那么对各种新建机组大家看要求水冷的标杆水平是270克每千瓦时在约的机组也做出了相关的规定那么对大气污染物排放也非常明确。那么烟尘要求小于10个毫克每立方米，二氧化硫小于35个毫克每立方米，氮氧化物小于50毫克每立方米这个应该说是全世界最严的排放标准，在中国被称之为超低排放。那么从这个政策上可以看出来，从2004年到2022年，不管是新建机组还是在约机组对这个煤耗要求都是逐步下降的所以从这个趋势来看实际上主要有3方面的政策。第一个，建设全世界最先进的机组最先进的机组。第二个是对现约机组就是在运行的机组进行改造。第三个是淘汰落后的小机组。所以第二部分想跟大家说一下这个实践情况。 那么在这个机组的容量单机容量的发展上大家看，国外在上个世纪应该说都远远领先于这个中国中国和国外的差距基本上在30年甚至更长。那么进入21世纪中国这个建设的都是高参数的大容量的最先进的技术。那么从这个蒸汽参数来看，也是21世纪以后中国建设的这个机组的容量蒸汽参数都是越来越高现在是超临界二次再热的最先进的。那么这个是给大家看一下，就是这个蒸汽参数和发电效率之间的关系红颜色的代表这个发电效率，绿颜色的代表清洁效率，就是说实现超低排放以后的效率。那么从这上面大家可以看出来最先进的机组和这个落后的机组之间相差能达到3倍3倍所以这个淘汰这个落后的机组就可以降低煤耗，实际上就减少耗煤量。那么这个是给大家介绍一下有代表性的这个机组。2006年中国建成第一个超临界这个发电机组，在浙江玉环就是这个超临界100万千瓦的那么2010年在宁夏宁武建成了100万千瓦的世界最大的单机容量空冷机组2013年在四川白马建成了世界最大的循环硫化床机组60万千瓦的2015年在江苏泰州建成了世界首台超临界二次再热的100万千瓦机组。那么2021年就是去年在安徽平山建成了世界最大容量的135万千瓦煤耗最低的这个机组，这个发电就是供电煤耗小于251克标准煤每千瓦时。这个是上海外高桥3厂就是机组这个煤耗情况大家可以看，在2011年它就达到了100万千瓦世界最低的水平这些年一直保持这个同类机组的最低水平就是超临界的那么除了建现建的机组，还有就是说刚才前面提到的改造那么这个是天津郭能京能滨海电厂天津郭能京海电厂就是对现有机组进行供热改造的这个情况。去年入选了生态环境部对外中心“一带一路”的典型案例实际上就是建设了4台吸热式吸收式热式热泵吸热式热泵回收气能发电机排气部分余热并进行供热，同时在脱硫吸收塔脱硫吸收塔的顶端，就是这个吸收塔的顶端加装这个降温冷却器，就是回收这个焰气的余热那么实现了每年回收120万吉焦的热量节约标煤4万吨，减少二氧化碳10万8千吨那么每天减少淡水耗量2800吨，脱硫降温冷却系统焰气温度由55度下降到45到48度回收热量每年增加收益3360万元人民币，相应减少烟尘4万吨，二氧化硫烟尘8吨，二氧化硫烟尘4吨，二氧化硫8吨，氮氧化铂16吨。 这个是节能改造的。那么淘汰的机组情况，那么就是说，国家主席习近平在这个第16届G20峰会上就专门介绍了过去10年中国淘汰了1.2亿千瓦落后的煤电装机大家可以看这个淘汰的力度还是很大的。另外给大家介绍一下就是超低排放情况前面也提到，那么超低排放就是指燃煤电厂大气污染物排放烟尘小于10个毫克每立方米，二氧化硫小于35，氮氧化物小于50。那么跟世界上其他国家发达国家进行比较，大家可以看我们中国这个尘、二氧化硫、氮氧化物都是全世界最低的所以叫超低排放就是说不仅要低碳发展，而且要清洁发展。大家可以看这些年来我们国家这个排放标准是持续下降的那么烟尘从1991年的600毫克每立方米下降到现在的10个毫克每立方米，二氧化硫从96年的1200毫克每立方米下降到35个毫克每立方米，氮氧化物从96年的650下降到50毫克每立方米，所以下降的幅度是非常大的那么这个超低排放从15年开始14年、15年开始，那么这个建设的速度也是非常快。2016年底全国完成超低排放的机组达到了4.4亿千瓦占全国煤电机组容量的49%。那么到2020年那么我们这个超低排放机组容量已经达到9.5亿千瓦，占所有煤电机组容量的88%。那么还有10%几是没有搞超低排放，实际上好多是小机组也就是会被淘汰的那么在这个实施超低排放这个过程中，标准体系非常重要。我们建立了，就是我这个团队建立了5位一体的这个技术标准体系包括这个排放标准主要是明确排放的要求那么明确要求之后，就建设了就是制定技术导则技术导则，那么就是说规定的实施这个超低排放的技术路线，就是不同情况下怎么实施第3个就是工程技术规范，那么就规定建设的要求、工程实际、建设、安装等等要求第4个就是说性能检测那么就是验证工程的效果。第5个就是运行管理规范技术规范，那么就是指导有效运行，那么可以实现污染治理设施设计好、建设好、运行好的有机统一，促进了世界最大的清洁煤电体系的建设。这个是第2个案例就是这个改造的就是节能改造的。那么这个就是说这个北京华能达这个公司在越南海防电厂采用柔性接触舌密封技术就是空气预热器进行改造那么改造以后，这个空气预热器的漏风力从15%下降到6%供电煤耗下降4.61克每千瓦时，项目每年节省8298吨标准煤，相应减少二氧化碳2万多吨这也是节能改造的技术那么第3个就是这个给大家介绍的生态环境部对外中心评选的减污降碳系统增效的技术，是江苏农进科接 就是对催化剂啊，因为现在都脱销厌气脱销 ，SCR 啊就脱销这个粉体，就是废弃的粉体进行资源化利用啊，进行资源化利用啊，那么每年就是说可以利用4万吨粉体啊，实际上就是说减少这个钛铁矿冶炼20万吨，那么相应的每年可以减少12万吨的二氧化碳的排放啊。那么由于我们国家在超低排放做出的贡献那么就是2019年中央电视台专门到南京对我进行了采访阐述了超低排放取得的效果。那么大家可以看，从2000年以来，我们国家火电机组就是这个是持续上升的容量那么占比容量占比也是持续下降的那么就是发展的可再生能源，也就是非化石能源。那么实际上就是发电量占比，就是容量占比那么我们现在的发电量煤电的占比已经小于50%了那么大家可以看2000年以来我们国家这个火电的发电量实际上跟2000年相比增长了是4倍的关系是4倍的关系。那么烟尘、二氧化硫和氮氧化物都比丰泽下降了90%以上。这个显示，这张片子显示的是我们国家这个火电机组的效率持续上升的过程那么怎么上升的就是刚才前面讲到的，建设最先进的机组，淘汰落后机组，改造运行机组所以这个效率持续上升。那么相应的就是发电煤耗供电煤耗持续下降。这个上面数字是供电煤耗那么2021年已经下降到302.5克每千瓦时就是供电煤耗发电煤耗也持续下降。那么这个是厂用电力和线省力，这个是线省力就是线路输送线省，这个是厂用电力都是持续下降的现在已经下降到小于6那么在这个过程中，实际上就是说，相比2005年也就是从2006年到2020年，我们国家就是火电行业二氧化碳减排达到185.3亿吨那么主要是通过降低供电煤耗降低供电煤耗就是发展非化石能源主要发展水电、核电、风电、太阳能就是说减少排放另外就是降低先省那么就是说减少就是降低供电煤耗这个下降的比例在30多，那么有60多是这个发展非化石能源降低这个先省呢，大概占比只有2%这个是减少二氧化碳的排放。第三个想跟大家说一下我们下一步的目标这个实际上是联合国 IPCC 得出的，就是不同发电形式排放的二氧化碳全球排放的二氧化碳这个强度，大家可以看出燃煤、燃油、燃气这都是高碳的高碳的。那么发展可再生能源，那么可以这个非化石能源特别是可再生能源，那么是可以减少二氧化碳排放。那么今年的3月15号，国家主席习近平主持召开第9次中央财经委员会会议研究就是实现碳大峰、碳中和的基本思路和主要 措施啊，明确提出啊，要控制化石能源总量，着力提高利用效能，实施可再生能源替代行动，深化电力体制改革啊，构建以新能源为主体的新型电力系统啊。那么呢，就是我们国家这个发改委啊发布了关于开展全国煤电机组改造升级的通知，就是国家发改委和能源局发布了“十四五”现代能源体系规划啊。国家发改委和国家能源局发布了关于加快推动新型储能发展的指导意见啊，这个都是去年和今年发布的。那么我后面的预测这个目标预测主要基于这3个文件啊。那么这个是我们国家安装的火电机组容量历年的容量啊。那么就是说12年火电机组是8亿多千瓦那么到2021年已经达到了12.96亿千瓦那么根据这个预测结合前面那个3个文件那么到2025年，中国的火电机组容量将达到14.47亿千瓦，到2030年将达到15.07亿千瓦这个就是火电机组这个发展预测那么这个就是说发电量预测大家可以看刚才那个容量是增长非常快的有一定的增长。那么大家看，就是我们的火电发电量2025年和2021年相比，以及2030年和2021年相比，都是下降的下降呢，实际上就是说。那么非化石能源的发电量，2025年预计将达到39.2%，2030年就要达到50%就非化石能源发电量占比逐年上升就是非化石能源发电量占比情况将来就是上升的会更快一些。这一个就是利用小时数就刚才讲的那个装机容量上升发电量下降，就火电实际上就是利用小时数下降的实际上就是火电将越来越多的起到调节作用促进可再生能源，就是风电和太阳能发电上网。那么这一个是预测火电机组的煤耗，就是供电煤耗和厂用电力那么从这个上面大家也可以看出来2021年我们是302.5克每千瓦时，到2025年将下降到2992030年预计下降到294克每千瓦时，煤耗次数下降。那么全国总的发电装机容量2020年是22亿千瓦2025年将超过30亿千瓦2030年将达到38.56亿千瓦，就是总的容量。那么这个是火电容量火电的容量这个地方可能少了一个一好像少了一个一。那么这个是水电的容量水电将达到4.3亿千瓦就是核电风电、太阳能另外呢就是新型储能新型储能就是这个抽水蓄能以及新型储能都会得到快速发展，主要是为了满足可再生能源，也就是风电和太阳能发电上网的需求 那么这个是发电量情况啊，这个是发电量情况。那么这个就是2030年啊，就是总的发电量啊。那么这个是火电的啊，水电、核电、风电、太阳能。那么就是大家可以看一下非化石能源发电量的占比啊，会提高很多啊，这样达到50%啊。就是说有一半的电量啊是不排放啊，基本不排放二氧化碳的啊。这个就是我想跟大家报告的主要内容啊。这个报告中的很多数据都来自于就是我写的这个2篇文章啊。一篇是在这个电力科技与环保今年的还有一篇是在这个环境保护这个期刊上所以大家如果有兴趣的话有什么问题有兴趣都可以去查阅这2篇文献如果有什么问题在以后的工作中也可以通过这个邮箱跟我联系再次感谢大家，谢谢。
Thank you, Dr. Zhu, for this excellent and brilliant analysis and insights on policies and practices for low carbon transition in the coal industry. As we understand that a large fraction of the power comes from coal power in China, and it is going to be particularly a significant challenge to how to transition into other technologies. Of course, I see from your presentation that China has made a great progress in terms of reducing the intensity of reducing much less coal than the rest of the competing markets, but still there is significant emissions that still contributed by the coal industry. So towards the end of this session, I would have a couple of questions addressed to you, and I'm sure some of the participants would also like to pose a few questions. So that will save for the Q&A session. So next, I would like to invite Dr. LI Yeqing, Executive Vice President, China Building Materials Federation. He is currently the President and Party Secretary of the Hussain Cement Company Limited, and also serves as the Director of the Technology Center as a Research Institute, Executive Vice President, Executive Director of the Expert Committees, and he's also the President of Hubei Building Materials Federation, Deputy Director of State Key Laboratories of Silicate Building Materials, and he's also an adjunct professor and doctoral supervisor of Wuhan University of Technology. So we are privileged to have Professor LI Yeqing. Over to you, Professor Yeqing.
Okay.
Professor Yeqing, you are on mute. Please unmute.
Okay, good. Do you hear and listening to my speak?
Right.
Okay, good. Ladies and gentlemen.
Mr. Lee, we cannot hear you. Please unmute.
Yeah, do you
Yes,
find
we can
me?
hear.
One moment.
Mr. Ronald. Yes.
All right.
We can
Okay.
hear.
So perhaps I'm going too fast. I'll have to wait for the translator. That's all right. My apologies.
Okay. Do you hear me?
Yes, we can hear you.
Okay, good. Okay, ladies and gentlemen, good morning and good afternoon. I'm LI Yeqing. I'm very pleased joining this training program. On behalf of the China Building Material Federation, I will give the introduction on the policy and the practice for low carbon transition in Chinese cement industry. Okay, my report includes 3 parts. Firstly, I will introduce the current situation of the carbon emissions in China cement industry. And then I will introduce the policy and practice on carbon reduction. As you know, the cement is necessary the building material for the social development, as well as the most important is raw material for national economic construction. From this graph, we can see the cumulative cement consumption per capita shows the rise, the trend. In the past 70 years, the global cement production increased by the 34 times, while the growth of the global population is less than the 3 times. The growth of the cement production is much quicker than the other materials such as the steel. The emissions in the global cement industry is huge. However, the Chinese cement consumption has reached the peak and will decrease gradually. But the cement consumption in the other developing country will increase continuously. In the worldwide, the cement industry accounts for the 77% of the total the CO2 emissions and account for the 5% of the global coal consumption. So we are facing the big pressure. Let's see the China currently situation. The total CO2 emissions is about 10 billion to 11 billion tons. Emissions from the cement is about the 1.3 to 1.4 the billion, which account is about 13% of the China total amount, ranking the 3rd place next to the electric power and the steel industry. Then, where it starts the carbon emissions in cement industry come from? Let's see. Let's look at this carbon emission account. In this emission is a scope in the cement product in the process, referring in the relevant stand of some international organization like the IPCC and the CSR, analysis from the cement production process. The emissions source in the cement clinker production mainly include the directly emissions and the indirectly emissions. The total here is shown is emissions type and accounting scope in each process. The relating the basic data acquisition is needed in the carbon emissions accounting. The data includes the 3 aspects. The first aspect is data come from the process. You know, this like the clinker production amount, the calcium oxide as magnesium oxidase content. The second aspect is come from the fossil fuel emissions, includes the consumption and heat value of the fossil fuel, as well as another 2 factors, includes the carbon content per unit heat value and the carbon oxidation rates. The data found the value of the 2 factors could refer to the international stand like the IPCC. The third part aspect is the data come from power, includes the power consumption data. Here, I would like to explain the power emissions factor. Since the power structures are different in each country or area. For example, Some coal power, the mainly, some is hydropower. The power emissions factor should be the 1:5 and design the basis average level of all countries. Let's look at this data of carbon emissions in the world cement production process. We take this NSP king as an example, which is the typical and advanced pre-consignor the king system in China. From this system, we can see the carbon emissions per ton clinker is around 860 kilogram per ton clinker, or 850 clinker is better the practice. As to emission source, the carbonate decomposition account for the 61 to 63%. This about 525 to 545 kilogram per ton clinker. Emissions from this aspect depends the clinker, the component, whether the alid is a C3S is higher or low. Emissions from the fuel account about 35%. This means about 300 to 315 kilogram per ton clinker. The third source is purchased electric power, which account from the small purchase, the 2 to 2.5%, about the 16 to 21 kilogram per ton clinker. This is about the clinker aspect. When we use this clinker to produce cement, we assume the clinker factor is 60 to 80%. So the emissions from the clinker is 516 to 688 kilogram. The power consumption of the grinding is a different system, but the scope is between the 28 to the 40 kilowatt hours per ton the cement. So emissions from this side is 17 to the 24 kilogram. This calculation is based on the China average. The power emissions factor is this factor is look at is 0.61. Therefore, the carbon emissions of the world cement process around about 524 to 748 kilogram per ton cement. This about the mentioned data is the basis on the NSP king. In other countries or area, there is a different process. So what is the difference? The difference is aligned the heat consumption, which we so-called the fuel emissions. Look at this table. Take the West. The weight process, for example, the heat consumption is 1,300 to the 1,500 the kilocalorie. The process carbon is similar. The average the process is similar. The impact of the power impact is also not so big, but the fuel emission reached to the 600 kilogram. The total, the clinker emissions close to the 1,100 kilogram per ton clinker. Which is higher than a lot of the NSP, the line. The heat consumption of the George Hill, the king is 900 to the 1100 kilocalorie. and the clinker emissions is close to it's 1,000 kilogram. This is the part that me is introduced the policy and emission reduction of the China cement industry. As we know, the September of 2020, the President Xi Jinping announced at the 75th session of the UNIT's National General Assembly, the China will seek to achieve the carbon emissions peak in the 2030 and carbon neutrality in the 2060. In the following more than the 1 year time, the President Xi Jinping restarted the commitment near the 10 big international oceans. This is the China sense of the responsibility to advance the building a human community with a shared future and involve the requirement to achieve sustainable development. From this graph, we can look at specifically the government has designed the action to peak emissions, which the three phases of the 2025, 2030, and the 2060 goals. In the 2025, the economic system of the green, the low carbon circular development will be the primary rate. Energy utilization efficiency is a key industry will be improved a lot. Energy consumption per unit the GDP will be reduced by the 13.5% compared with the year is 2020. And the CO2 emissions per unit GDP will be reduced by the 18% compared with the 2020. Consumption ratios of the no fossil energy will be reached up to the 20. When come to the 2030, the low carbon transit will be achieved remarkable result. CO2 emissions per unit GDP will be reduced by about 65 compared with year is 2005. Consumption ratios of the no fossil energy will reach up to the 25. Forest coverage will be reached to around 2025. This page we can find the government design for the big. When come to the 2060, the energy utilization efficiency will achieve international advanced level. Consumption ratios of the no fossil energy will be reached about 80%. And the carbon neutrality will be achieved. The 10 big action include the clearly green energy, circular economic, energy saving, and carbon reduction. Here, we can look at the key proposal for high energy consumption and high carbon emissions industry, such as the coal, electricity, the steel, electricity, aluminum, and the cement, and the petrochemical. To achieve the technical reconstruction and upgrade, as well as the central control the capacity. From this, the page for the cement, we can find the cement industry in China. The control both the quantity and the intensity of the energy consumption is the big lever of for the China, the government to achieve the emissions peak and the carbon neutrality. NDRC, the proposal, the main goals for the industry include the cement in the October 2021. It's required the capacity with advanced level of the key industry include the cement have to exceed the 30 in the 2025 by means of the implementing energy saving and carbon reduction action. The main measurements indicator is comprehensive the energy consumption per unit clinker. The advance is required to the below is 100 kilo the standard coal. The basis the qualified level is 117 the kilo is the standard coal. Unqualified the production line are required to reconstruction and upgrade or even eliminate. On the other part, the Chinese carbon trade, the market grows very quick. The first, the pilot, that take place in the Shenzhen in the 2013. Then the national uniform the market of the carbon emissions right trade start up online trade from the formally in the July and 2021. At this time, 2,162 the power generation the company were covered in the first bunch list. As per the planning, the key industry include the cement and the steel that will be included in the national carbon market in the 14 and the 5 years plan, the period. The speed up the carbon reduction, the progress. For this third part, I want to introduce some the practice of the Chinese cement industry to reduce the carbon. This is the concept which I will proposal. The green and the low carbon, the building material in the world life cycle. I divided into the 5 phases. From the beginning, the production of the production to the final the recycling of the building production, and the life cycle, the green and the low carbon the management can be done from the 5 phases. As you know, the first part is our raw material and quarry the money. How we can reduce the carbon here? The curve is to use some alternative raw material and the fuels in the biggest degree. The main practice is use some industrial waste and domestic waste in the cement production, such as using some industry the byproduct like the carbon slag and magnesite slag as the raw material. This discarded the slag contain the calcium oxide, but not in the form of the the vacuum the carbonate. When used in the process of the carbon emissions, will not generate in the production process. However, this is not a main method. The main method is use the alternative fuel to substitute the fossil fuel like the coal, the natural gas, and heavy oil. The method also includes the use of biomass, industry and domestic waste to make alternative fuel. The second part is how to use this fuel to production the process, how to improve the production the process efficiency and the labor. The third part is about the logistic in the production the process, include the raw material transportation, product transportation. The fourth part is about the structured management on the carbon emissions in the process of the turning cement into the concrete or concrete the products. The last part is trying to best to conceive the building the life cycle with the design it, and the conceive the for how to recycling the building material when the life cycle is over. This means that we can use some the waste material in the waste the building and into the building material again. Seeing from the reduction the potential, we know the reduction the potential from the process is a low, but impact is from the process emission is high, where we have to really on the external the carbon the zinc technology to balance. Our real the priority is on the fuel and electricity aspects. Emission reduction from the fuel aspect has highest the potential as well as a high impact. Electricity aspect also has a high the potential, but impact is low relative. This paragraph is a typical is NSP process. The previous page already showed some of the carbon emissions in the the process of cement production. Then one answers the reduction the potential of each step in the production process in the more the detail. Let's take the modern advance and the new dry the process. For example, we already mentioned. And the first step is quarry the production. This is what is we call the mining, from the drawing, blasting, and to the transport and to the crushing. The potential here is not so high. We are only the several kilogram. The second is alternative the raw material. We call this the certain the potential here is honestly is high. Use some no calcium the carbonate the type the industry the waste we already mentioned. However, since the availability of the industry the waste is limited, the total reduction the potential is not so high. The third is the alternative the fuel. which have the biggest contribution if we use not the fossil fuel completely, such as biomass, industry waste, and the potential should be the 140 and 285 kilogram to the emissions reduction, which is high the potentials. The fourth is the fuel efficiency optimization, which is we call the fuel efficiency. This includes increasing the improve the heat exchanger efficiency to of the preconditioner and clean the production as well as the cooler. The efficiency improvement can be reduced the heat consumption of the system significantly. So there is also the certain potential is here. The fifth aspect is waste heat recovers the system generate the power. As we know, the nearly of the Chinese cement industry production line equipmentally with WHR system. In our plants, the 20 to 30% the power is provided by the WHR system. Here, the potential is about the 30 to 45 kilogram emissions reduction. The sixth, the factor is the clinker utilization factor, where the potential is competitively is high. Now, we produce the blended cement instead of the OPC cement. Some are produced with slag or pozzolana. Therefore, the clinker factor is reduced significantly. The reduction, the potential is also very high. It's about 120 to 170. The seventh is development of the low carbon clinker. This is the leading edge technology, where these people try the best to reduce carbon dioxide and the silicon rich. The carbon emissions in the clinker production can be reduced. The eighth is energy utilization efficiency. It's in the grounding. We need continued development, energy saving the grounding equipment, include the raw material grounding system and the cement grounding equipment. The ninth is the intelligence system. Intelligent system. That is the improve the process, the control the level of the operation through the digital and the intelligence management. Here, we can achieve the 5 to 10 kilogram the emissions reduction, include our smart production process. The final is development and the utilization the new energy. This has the very high potential. Besides using the alternative fuel as more as possible, we will use a lot of clean energy, such as the solar energy, the wind power in the future. And sure, we also don't want to use fossil fuel finally. Instead, we use hydrogen, the energy to replace the coal. And to the hydrogen, we also have a design to use the solar energy to electricity water in order to produce hydrogen. Now, the key is elements is cost. The finally is 11, is a CCUS. As you know, it's for the cement industry, is not could use any the technology reduce by himself the carbon. We need the CCU, and the CCUS is to the saver the last part is 160 to the 350 kilo. Is our industry is very difficult this part. Just now, we can mention the reduction of potential from the quarry and the mining raw material is not too high, and the overall emission is not so big. We're about below the one kilogram the reduction the potential, which includes the rehabilitation around the quarry. The production is a big operation. So you can look at this picture. For this paragraph, as you know, they are the mainly the grounding the system for the raw mill production, and the traditional is the ball mill system. The currently the more and more the use and the vertical ruler mills, you know, just like this one, and the ruler price. There we have the data about the consumption of the different the mill system. Is the same the production the quantity. We can compare this table. We can look the emissions of the ball mill is about 20 the kilogram. The emissions of the vertical ruler mill is it's 15, and the emissions of the ruler price is 13. Based on this data, we can prefer use vertical ruler mills and ruler price system. This is what we can previously mention: the emission reduction, the road through the energy saving the equipment. This is the biggest contribution in and the most important step in the clinker production. Namely, so it's called the heat work system and alternative fuels. Here we have the active data about the emissions reduction amount by the Chinese cement king to use the alternative fuels. On one hand, we can reduce the use of the fossil fuel to reduce carbon emissions. On the other hand, this can mitigate the land resource tension caused by the west landfill, as well as the saving the investment for the nearly the building the west disposal infrastructure, and reduce the CO2 emissions from the disposing the west. Besides, the cement king, the co-processing also can reduce the methane emissions from the landfill. And the 60% exhaust the gas from the landfill is methane. It's methane. It's a potential of the which can the global the warning is 21 times higher than the carbon dioxide. Compare with West power generation, the heat to the power the transform efficiency is lower than used as alternative to the clinker the production. For the generated power system, the efficiency normally is 20%, but for the cement production, we can achieve it 65%. Since from this result, when use the 1 ton alternative the fuel, the carbon emissions could be reduced 50 to 70%. In China, alternative fuel are the coverage into the 6 types, includes the municipal solid waste, municipal sludge, and the general industry waste. Industry hazardous waste, construction demolished waste, water floating objects, and agriculture the waste is the 6th part you can find. Currently, alternative fuel is more and more used in China. So that's the Hussain cement. The biggest alternative fuel, the labor in the Hussain achieved the 30%. However, the national average, this labor is not so high, only the 2%. The highest, the alternative fuel, the labor is from the developing country in the European and the Northwest European. Some country can achieve 70%. This is an important direction for the China cement the company to work toward. Let's see the aspect that improve the clinical heat efficiency. As we introduced previously, the compensates the heat consumption of typical the modern NSP is about 740 kilocalorie. And the carbon emissions can be reduced if we simply use the system. However, we can see the more from the full system include the steam that generate from the clean exhaust gas. We use this steam to generate power can bright some heat efficiency. If we can use this steam to manufacture some the building material, the product, the heat efficiency can be improved at a much more than extent. Heat efficiency improvement means the reduction of the system carbon emissions. The Hussain cement is testing a new technology, which is transform the current concrete brick to into the CO2 and the current the line. Means it's by using exhaust the gas from the cement kiln. After the testing, the average the compressive stress of the bricks can retrieve about 15 megapascal, which can satisfy the relates required fully. On the other hand, each brick can absorb the 30 grams of CO2, which efficiently reduce the carbon emissions in the future. As the cement the grounding system, the power consumption for the traditional ball mill is 39 kilowatt hours, and the carbon emissions is 24. Now we use a lot of the ruler price plus the ball mill system, includes the pre-grinding and the alternate grinding and the Soomro final grinding system. The consumption can be reduced from the 23 to the 18. We also have the vertical the ruler price, the mill, as separate the final grinding system. The carbon emissions, which is very low, only the 17. Overall, no matter the ball mill and the vertical ruler mill system, the difference the carbon emissions is only 6 to 7 kilo. Considering the total cement the carbon emissions amount, the difference is very limited. So the biggest impact is the fuel. There are also some emissions from the concrete and aggregates. From this table, and we can see the carbon emissions from concrete with the different the grade from the C15 to the C50, includes the carbon from the cementitious material, gravels and aggregates and additive. It's about 105 to the 300 finally. The key achieved the carbon reduction of the concrete is to reduce the cement the carbon emissions and use of the cement material. And the last page. Let's see compare the compensates the energy consumption reduction, the potential, the king line with the different capacity. Currently, there are more than 1,600 cement line in China, which is the biggest capacity is 14,000 tons per day, and the smallest is capacity just 1,000 tons per day. We select the typical capacity line, which is 5,000 tons per day. Another is 2,500 tons. The calculate the basis on the generate the field program, and the energy consumption, the 5,000 is low for sure. But however, if we use some the weight of the alternative the fuel, the AF ratios of the small capacity line is high. And because the same AF amount can satisfy the smaller capacity line better than compared with the biggest capacity line. Finally, speak, and compensate the energy consumption is similar. The line with the smaller capacity can be reduced much more easily. This is the result we get from the scientific of the calculation. This is it's my presentation. Here is we show the China is the cement industry, the policy and the practice for the low carbon transitions. That is all I must my introduction. If you have any question, I'm very happy to answer, give you some of my answer. Thank you very much. Thanks for your attention.
Thank you, Dr. Lee, for sharing excellent insights on how China is undertaking its transition to, lower carbon cement production, and pretty much impressed with the progress that you have made in the cement industry. So for sure, we would have some questions from the participants, and perhaps we can, if it is okay, we can take it at the end towards the Q&A session. I think right now we should go for a short break for about 10 minutes or so. Please help yourselves. So yourselves tea, coffee, whatever the options you have, and we'll be back at 12:44. Dr. D, that is okay?
Okay. 郭老师稍等一下，我们休息10分钟。Yes.
Ah.
Okay. We will have a 10 minutes rest.